Approximation of the slope of a tangent line. What again are secant and tangent lines? Given the graph of a function defined by y is equal to f of x, the secant line is the line that intersects the graph at 2 points. The tangent line is the line that intersects the graph only at 1 point. So given a graph that is shown to you by the green curve, the red line is the secant line. The blue line is a tangent line. How do you find the slope of a line that is tangent to a curve defined by y is equal to f of x? So we know the function. We know the equation that defines the function y is equal to f of x. But we are not given the equation that defines the tangent line because if we are given the equation that defines your tangent line, let's say for example it is equal to y is equal to m times x plus b. So it's easy to know the slope of the tangent line because that is just that. That is just m. But here, in situations wherein we shall talk about a line that is tangent to a curve, we only know the point of intersection or the point of tangency. But we don't know the equation of the tangent line. We also don't know the slope of the tangent line. Well, this is what we can do. We can do it through approximation. And by the way, we will use the symbol or notation m sub TL. So m sub TL stands for the slope of the tangent line. So that is the slope of the line that is tangent to our curve at that point. And so in this example, our point here has coordinates 1, 1. Look at that. Okay? 1, 1. Okay, so this is what we can do. We can do it by approximation. We will begin by drawing a secant line. A secant line that intersects the curve at 1, 1. Look at that. And you can pick another point in the curve. Okay, so to make an easy computation, let us just pick this point because the coordinates of that point is just 0, 0. So it's easy to compute for the slope of the secant line. It's change in y over change in x. So what is that? So our change in y, okay, slope 1 is equal to 1 minus 0 divided by 1 minus 0. So that is just 1. So that is not the slope of the tangent line. That is the slope of the secant line. And I know it's far from being the slope of the tangent line. Well, guess what? This is what we can do. We can produce another secant line that is now closer to the tangent line. How about that? And what we do next is, again, using change in y over change in x, we will produce our second estimate for the slope of the tangent line. So it's still, it's not the same slope of the tangent line. It's far from being the slope of the tangent line. It is the slope of the secant line. Well, guess what? We can get closer to the tangent line. So we will pick a point in the curve that is close to the point of intersection. And that point can be this one. And we can produce its coordinates because we are given the function that defines our curve y is equal to x squared. And so we can produce this point. So x is equal to 1.8. Okay, so x is equal to 0.8. And y is equal to 0.8 squared. So you now have a pair of coordinates for point C. The rest follows. Compute for our M3, our third estimate for the slope of the tangent line. So it's change in y over change in x. So you know what's going to happen, okay? You know what's going to happen when we shall do it through approximation. So we have a curve that is defined by y is equal to x squared, and we are concerned with the slope of the line that is tangent to our function y is equal to x squared. And the point of intersection between our function and the tangent line is this one. This one has coordinates 1, 1. So our goal is to produce an approximation of the slope of the tangent line. And we shall do it through a sequence of secant lines. We will compute for the slopes of a sequence of secant lines. You can do that. You can do that approximation. You don't have to do it manually. Okay, you can do it with the help of Excel. You can put the values of x, and this x's begins with 0. Okay, and then I will produce a sequence of secant lines that will approach, the tangent line. And as the secant line does it, it produces a point of intersection. Okay, so these x values, the x coordinates of your point, that can be arbitrary, but it must be less than 1. Okay, this is our direction in the values of x. So we can, starting from 0, we can begin from 0 and then add an increment of 0.1. Okay, 0. The y coordinate is 0 squared. Okay, and then when our next values of x, okay, look at that, is 0.1, the y coordinate is 0.1 squared. And when we get to our third point, okay, we add 0.1 again, so it's going to be 0.2, that's the x coordinate. The y coordinate is 0.04. 0.2 squared is 0.04. So as our secant line approaches the tangent line, you are producing here a pair of points. This one is constant, it's 1, 1. And these points have a pair of coordinates. And so given 2 points, we can compute now for our slopes. As the secant line approaches the tangent line, the slopes that we are getting is approaching the slope of the tangent line. It turns out here that our approximation gets to a value of 2. So our approximation after 11 computations for the slope of the secant lines, our approximation is the slope of that line that is tangent to our curve when x is equal to 1 and y is equal to 1 is equal to 2.